Welcome, everyone, to your high-yield final review session. I am literally so thrilled to be your guide today. Look, if you've been staring at anatomical charts until your eyes cross, just take a deep breath. We've got this. Today, we're going to act like architects. We are building the thorax from the ground up, starting with the bones of the spine all the way to the vital organs packed inside the chest cavity. By the time we wrap up this explainer of our anatomical source material, you're going to walk into that board exam with absolute confidence. Let's dive in.
Here is our game plan for today. First, we'll lay out the thoracic vertebrae blueprint. Then, we'll learn how to spot those tricky, atypical thoracic vertebrae. After that, we'll cover thoracic joints and ligaments, map out the mediastinum borders, and break down the mediastinum subdivisions and contents. And finally, we'll wrap up with a rapid-fire exam review to lock it all in.
Section 1. The thoracic vertebrae blueprint.
Okay, so in anatomy, you really can't recognize the exceptions until you've totally mastered the standard blueprint, right? So let's run through our high-yield checklist. The thoracic vertebrae form the central axis of your upper back. Picture them right in the middle of the spine. They have these really distinct heart-shaped bodies. The vertebral foramen, the hole for the spinal cord, is surprisingly small and circular. They also feature these long oblique spinous processes that point downwards, almost overlapping like shingles on a roof. Oh, and here is a massive structural point. They actually increase in size as you go from top to bottom. Makes sense, right? Because they have to support more and more of the body's weight.
And this brilliantly illustrates exactly how the ribs anchor to that bony axis. If you consider a typical vertebra, you'll spot the superior demifacet right on the side of the body. That is exactly where the head of the rib sits. Then, check out that thick, sturdy transverse process extending outwards. There's another facet right there, which is specifically meant to articulate with the tubercle of the rib. Having these dual attachment points, that is the secret to the ribcage's incredible structural integrity.
Section 2. Identifying atypical thoracic vertebrae.
All right, now that the standard blueprint is burned into your brain, we need to talk about the rule breakers. Because let's be real, examiners absolutely love testing you on the outliers. It's a goldmine for board questions. While your typical vertebrae have two demifacets, the atypicals, that's T1, T9, T10, T11, and 12, do their own thing. T1 rocks a complete facet for the first rib. T9, it's missing its bottom demifacet entirely. T10 shifts its whole facet right onto the pedicle. And then T11 and 12 basically have large, circular facets primarily on their pedicles, and they completely lack any facets on their transverse processes. Let's put T1 in the spotlight for a second to see exactly why it's so unique. Instead of just a demifacet, it boasts an entire articular facet dedicated solely to the head of the first rib, along with a demifacet below it for the second rib. Plus, think about its spine. Instead of pointing downward, like the typical ones, T1 has a thick, long, and almost totally horizontal spinous process. It's built differently for a reason. It serves as that critical structural bridge between your highly flexible neck and your super rigid thorax.
Section 3. Thoracic joints and ligaments.
So, we have our bones, but to make a functioning human body, we've got to connect them. And these connections have a really tough job. They have to balance two totally opposing forces: rigid stability to protect your heart and lungs, but enough flexibility to actually let you breathe. Think about the back versus the front of your chest wall. In the back, we have the costotransverse joints. These are synovial joints connecting the rib tubercle to the vertebrae's transverse process, giving you that essential gliding motion when you inhale. Now, jump to the front. The sternocostal joints. That very first rib has a tough, primary cartilaginous joint with a manubrium, super stable. But ribs 2 through 7? They have synovial joints with thin capsules to give you that necessary flexibility.
The really crucial detail here is how the costovertebral joint, where the rib head meets the vertebral body, is engineered. This joint is actually split right down the middle into two separate synovial compartments by an intra-articular ligament. And to top it off, the fibrous capsule is reinforced at the front by a strong, fan-like structure known as the radiate ligament. Seriously, it's a masterpiece of anatomical engineering. It guarantees the rib stays firmly anchored while still being able to pivot.
And we absolutely cannot forget the ligaments tying the actual vertebrae together. Huge high-yield alert for you here, the ligamentum flavum. These are specific, vital ligaments connecting the lamina of adjacent vertebrae. Working alongside the intraspinous ligaments between the spines and that strong supraspinous ligament running down the apices, the ligamentum flavum is what ensures your vertebral column maintains its upright structural stability so it doesn't just collapse forward.
Section 4. Mapping the mediastinum borders.
Okay, we've built the outer cage. Now I want you to step inside and visualize the internal thoracic cavity as this massive 3D box. Just think of it like the walls of a room. Superiorly, the ceiling is your thoracic inlet. Inferiorly, the floor is your diaphragm. Anteriorly, the front wall is the sternum, standing guard over your heart. And posteriorly, the back wall is formed by those sturdy thoracic vertebrae we just mastered. Everything packed safely inside the central compartment, that is your mediastinum.
Section 5. Mediastinum Subdivisions and Contents.
Now that box is way too big and complex to study all at once. So anatomists draw an imaginary line right from the sternal angle straight back to the lower border of T4, splitting it into a superior and an inferior space. The superior mediastinum is densely packed. To convert this for the exam, I want you to use the mnemonic VAT, or VAT. Group the contents into veins, arteries, and tubes. For veins, you've got the right and left brachiocephalic veins and the superior vena cava. For arteries, the massive aortic arch and its branches. And for tubes, the trachea, the esophagus, and the terminal part of the thoracic duct. Just throw in the thymus gland, and boom, you've memorized the entire space.
Moving down to the inferior mediastinum, this area gets further split into 3 smaller parts: anterior, middle, and posterior. The anterior is just a tiny little space mostly holding remnants of the thymus. The middle is the absolute star of the show. It is completely dominated by the heart, its pericardial sac, the ascending aorta, and the pulmonary trunk. Finally, the posterior space, which sits right up against the vertebrae, houses the descending thoracic aorta, the continuing esophagus, and the thoracic duct.
Section 6. Rapid-fire exam review.
You've just absorbed a ton of high-yield anatomy in a really short amount of time, so let's lock it in with some active recall. Question 1. Think back to our breakdown of those exceptions. Which atypical thoracic vertebra completely lacks an inferior costal demifacet? I'll give you a second to think about it.
Got it? It is the 9th thoracic vertebra, or T9. Remember, T9 is atypical specifically because it only features the superior costal demifacet and is missing the inferior one altogether. Huge high five if you got that one right.
All right, question 2. Let's move to the front of the chest wall. What specific type of joint connects the first rib directly to the manubrium of the sternum? Remember, think about stability versus mobility here.
And the answer is a primary cartilaginous joint. You absolutely nailed it. This rigid connection is completely different from the flexible synovial joints found on ribs 2 through 7. It provides a rock-solid anchor point right at the very top of your rib cage.
Really great job today, everyone. Before we wrap up, I want to leave you with this final thought as you push forward in your exam prep. Just think about the sheer interconnectedness of the human body. From the exact angle of a tiny costal demifacet to the powerful tension of the ligamentum flavum, every single millimeter is designed for a specific purpose. If just one facet or ligament were to shift, how does that subtly change the shape, the movement, and the protective cavity of the entire mediastinum? Keep exploring that brilliant complexity. Best of luck on your exams, and I'll catch you in our next explainer of the source material.